I will hand over to Pete. So if you'd like to start your presentation, Pete, when you're ready.
All right.
And
Hopefully.
if anybody has any questions, you can add them via the Q&A feature and we will answer them at the end. Okay, fire away, Pete.
Brilliant. Hi, everyone. It's always a bit weird doing these webinars because I can't see anybody, but I presume you're there and listening away. And as Louise said, if you've got any questions, do stick them in the chat and we'll see what we can do to answer them later on. So today we're going to talk about river restoration. We're going to talk about delivering projects, why we deliver projects, and how we kind of know where to deliver them, and a little bit about what makes rivers good. So what we're actually looking for in terms of a good river. So let's start with the basics. Who am I? I'm Pete King. I am the director of the Ouse Adur Rivers Trust. I've been in this role for the last 8 years and have worked for the Rivers Trust on those two rivers for the last 15 years. So I also chair the Adur and Ouse Catchment Partnership. What do I know about delivery? Well, I've delivered about 125 different capital projects across those two river systems, which are just over 700 different interventions that we've put in. And this ranges from very small scale projects, which we'll talk about, to kind of large engineering schemes to do large scale landscape works. Um, and across kind of river enhancements, river realignments, and wetland creation. So I do know a little bit about it. I don't pretend to know everything about it, but hopefully we can go on a bit of a journey about what we've done over the past 15 years. So, what makes a good river? The theme running through this is looking at what makes a good river and why we do what we do. This isn't one of my rivers, unfortunately. This is one of the chalk streams in Hampshire. But this, hopefully, you can see just from this picture, looks like a relatively good river. So, what makes a good river? Well, uh, shape. Shape is a really important part of rivers. They meanders and the way they wiggle through the landscape are quite critical to river health. They allow different processes to happen in rivers, speed up and slow down water, and enable kind of a lot of the habitat features that we want to actually form in rivers. So what you can see here, this isn't in our area either, but it's a great example of a kind of river meandering through the landscape and starting to go through natural processes. So what we've got here on these bends is you can see on the inside of bends, water moves a lot slower than it does on the outside of bends. And that means that as water goes around the corner, it drops out the sediment that it's carrying and it creates these things called point bars. These are quite rare in our highly modified and straightened rivers in Sussex, but these are part of the process that rivers go through. And you can see that as it builds up on one side, it starts to erode on the other side, meaning that the channel is moving across the landscape. Uh, so straight rivers aren't great because they create a lack of flow diversity. Everything's moving at the same speed, and they're normally quite fast. And because there's no slow flow moving water, you lose that kind of dynamic sediment dropout into the system, which enables that habitat to form. And because they're fast, they also you get a lot of downward erosion or vertical erosion. And one of the characteristics of lowland rivers where we are is that they move from side to side. They actually erode and should erode laterally, so get wider and move across the landscape. One of the other problems with straight rivers is that they're a lot shorter than wiggly rivers. And that means that if you live on the coast or you live down near the bottom, you get a lot of water a lot faster ending up in your neck of the woods. So why have they been straightened? Well, here on the Ouse and the Ada and parts of the Arun, they were actually straightened for transportation, for canalisation. So the River Ouse, for example, was entirely straightened in order to build Balcombe Viaduct, where the train now goes over the railway line. So they straightened it to move all the bricks from the coast up to the top of the catchment, built the viaduct, got a train line, didn't need the canal anymore because now we had a train system. So sort of a 20-year project to build the viaduct has had a kind of lasting legacy on the condition of that bit of river. We also straighten them because it makes fields easier to manage and actually enlarges kind of areas of agricultural production. We've moved a lot of them and straightened a lot of them for infrastructure, so railways and roads. Uh, and the historic kind of flood risk thought process was that if you get water out of the catchment as fast as possible, that will be really good for flood risk management. Unfortunately for us, everybody lives on the coast and in the coastal areas. So actually moving water as fast as you possibly can to the urbanized areas doesn't always do the trick in terms of flood risk management. So we look for where the river has been straightened and we look at opportunities to uh, put it back to its historical course, so to re-meander it, re-wiggle it. So this is a project that we did up in Sheffield Park, so up near the top of the Ouse, and you can see there on the left is a map from 1798. So the canal was built, but there was also lot, which is the big thick line there. But there's lots of other channels. So that what's in that circle, that little thin line in the circle, is the historic course of the River Ouse. And you can see there by sort of the late 1800s, that's been completely lost. It's been completely cut off from the river, basically to allow boats to move much more simply through the river system. If you look at Google Earth images of river systems or LiDAR imagery of river systems, you can often see numerous kind of historic meanders and bits of river that have been cut off in the past. So here's that same place as a Google Earth image. So there's a kind of image that shows where that historical course of the river used to go through this field, and that's the Bluebell Railway just to the north of it. So back in 2012, we undertook a project to reinstate this course of the river through this part of the Ouse. So we reconnected the meander. As you can see, that's a completely different shape to the historical image. And one of the reasons for that is that the the old channel used to actually go through the woodland on the opposite side of the picture there. So if we'd cut the meander back to its truly historical course, we would have actually eroded into the woodland, which is a piece of ancient woodland. So we're quite keen to protect ancient woodland. So we had to re-engineer the meander slightly in order to get it to work and not cause detriment to other existing habitat. We did leave the old channeling court in its original place, and it's been cut off, but it's become a large backwater, which is a really important kind of refuge area for fish to hang out in. And it also means that you're not joining the woodland and the floodplain together, which can create land ownership issues if you start joining people's land together. So what this has done is it's created a channel that's actually about 400 meters longer than what was there before. So just by adding in those bends and wiggles, it creates a channel that's about 400 meters longer. That's obviously when we were constructing it. Whenever you construct anything, it looks an absolute mess and does so for quite a while afterwards. Anyone who remembers 2012, we had a very, very wet autumn and winter. So by the time we left, this looked even more messy. But today it now looks like this. So you can see that it's established, the land has been restored back to the floodplain meadow that it was before, and we've got a nice tree-lined kind of meandering channel back through the floodplain in Sheffield Park. But you can't always dig new channels. New channel digging is quite expensive. It takes up space, and obviously it does disrupt some of those kind of agricultural purposes that we're in the surrounding landscape. So these are both on the Ada, where again it's been straightened and for canalisation. So it's straightened to allow boats to move from the coast up to the Nep estate. And neither of these places it's possible to actually re-meander it. The one at the bottom actually goes between two landfill sites. So you definitely cannot remeander that through kind of contaminated land. So what we do with these is we actually work within the footprint of the channel. So we get into the channel and we build, these are constructed berms to actually create that shape that we're looking for within the river channel. The one at the top was done and we filled them in. So they're berms that have been filled in to kind of create that shape. The ones at the bottom we've left empty. The one at the bottom is a particularly sedimenty river. So these actually act as sediment traps as well. As the water level comes up, the sediment and the fine particles that are moving down the river are slowed down by the structures and they drop out behind them. And over time, they fill themselves in and naturally vegetate. So they're quite a good way of controlling sediment and also getting that kind of natural seed dispersal back into the system. So when we talk about shape, we're looking at wiggles, and we can do this through either diggers and large construction projects or through quite simple methods, obviously much cheaper, much quicker, and also gives you the desired effect in kind of constrained landscapes. So connectivity, rivers and connectivity is the next thing that they need. They need to be connected. They need to be connected to themselves and they need to be connected to the landscape. So this is a map of the Ouse. Every red dot on that map is a weir structure on the River Ouse. Weirs are really bad for rivers for lots of reasons. They prevent the movement of fish. So fish can't generally get up and down them. Some can in kind of high flows. You see the sea trout moving through the river system. We've got sea trout on our rivers. We haven't got any salmon, but we do have sea trout where I work, and they can get over most of these in kind of high flow conditions. But for a lot of species, and all fish species need to move around to some extent during their life cycle, these barriers create a massive problem. We actually have bits of the River Ouse in between some of these barriers where there are no fish because they can't get over them, and the ones that are there get washed downstream in floods and then can't get back up again. So these, you do end up with pockets of river that are completely isolated from fish. They alter sedimentation, they trap a lot of sediment, they raise bed levels, they alter the natural flow of river. You find water behind weir structures is really, really still, so it's known as being impounded. One of the critical things about rivers is they do actually need to flow, otherwise they're just really long lakes. So we do need rivers to flow. So by trapping water behind them and having very little flow, limited amount of flow, we actually deoxygenate the water and we remove a lot of the habitat that fish need in order to kind of spawn in. That deoxygenation can increase eutrophication. And actually, one of the biggest fish kills we've seen on the Ouse was actually behind a weir structure down at the bottom in a place called Beddingham. It's a big weir structure that stops the tide going in, and the water's very shallow. It's very still behind it because it's so full of sediment and very low levels of oxygen. And a couple of years ago, a big storm surge came over Sussex, and the change in air temperature basically and air pressure pulled all the oxygen out of the water and killed about 100,000 fish in that stream alone. So these barriers can have quite detrimental impact on kind of river health and the kind of species ability to survive through more kind of extreme weather events. But we know where they are. That's a bonus. Knowing where these things are enables us to kind of tackle them, and we can tackle them in a priority of which ones are opening up the most amount of river, but also in a series. There's no point spending lots of time and effort removing a weir structure if there's another one 50 meters up that you can't remove. So we try to do this in a strategic way. So here's a good one. This is at Buxted Park in near Uckfield. So this was about a 3.5 meter tall weir structure, but quite close to the bottom of the Uck. As you can see, that's pretty hard for anything to get over the top of. it serves no purpose. And we should say that some of these structures do serve a purpose and are required for flow gauging and other kind of monitoring purposes. But a lot of them serve no purpose in the kind of contemporary landscape. This was actually put in before Buxted Park was a hotel and it was a private residence. This weir structure was built illegally, basically to create a long section of slow water so that ducks would land on it, and then the landowner could shoot the ducks. So this has many, many detrimental impacts. You can see that kind of still water behind it. It looks quite long and straight. So we removed it, uh, and you can see by the pictures on the right there, hopefully the kind of that's about 6 months after we did it. So almost instantaneously you get kind of habitat forming. You can see better shape. You've got flow that's coming into the river. Because of where this was, it actually opened about 40 kilometers of river to migratory fish. So that was a barrier to everything. Not even sea trout could get over that. There was no records of sea trout upstream of that structure before we took it out. And again, the following year, through our fish monitoring, we started to see sea trout moving up through the system and fish diversity upstream increasing rapidly. The natural habitat's forming, and we're also getting a lot more plant life, and it's those plants that kind of give you that oxygen, and they give you habitat for fish. Some fish species spawn on vegetation in the river channel, so it's important that we get that kind of vegetation and natural recharge and allow those processes to start. But you can't always remove barriers either. So there's a lot of other barriers. There's a lot of road bridges that create problems. Uh, we get quite a lot of objection if we want to remove a road bridge. So we have to come up with other solutions. Uh, Gauging stations. So the picture in the top middle there is Ardingly gauging station. That's what is used to gauge how much water Southeast Water can remove from the river over winter. So it's an important piece of it's an important structure in terms of abstraction and flood risk management. So we basically put these technical fish passes on. These come in many different kind of styles. The one on the top left is actually a rock ramp. It's a lot of rocks just embedded into the riverbed, and they get bigger and bigger as they go up, and they actually drown out the bridge culvert. So there's no gap on the culvert. But as you can see, it's still allowing water to flow and move through that structure. And the one in the technical fish passes, like the one on the bottom left, which was actually put into a road bridge up near Linfield, which creates a passage for fish to move through. So the water comes through that black structure, breaks up, and attracts fish to go up and swim up through it into and through the culvert. And the one on the right there, bottom right there, is actually something that was designed by a student, a PhD student, and it's just a series of bristle brushes that you stick onto a concrete slope, and it's enough for the fish to get purchase on their tails and actually swim up through the structure. So again, some of these are quite complex, some of them are quite cheap and simple, but there's lots of solutions where we can't remove barriers. And so far, we've removed about 25 of those barriers on the Ouse. So we're about 10% of the way through removing or putting fish passes on to barriers. And we've just finished one catchment up in the Cockades Brook, which has now had all the barriers have been removed. So it's completely free of all kind of blockages to fish passage. So slowly, we're kind of knocking through these things. Connectivity isn't just about in-channel. Lowland rivers, again, lowland rivers are very characteristic of large, wide floodplains and wetlands and marshes. These are the characteristics of kind of lowland rivers. And we've disconnected them quite a bit. This is a picture of the Adur. You can see the embankments sticking up through the floodwaters there. The vast majority of that floodwater is actually coming from surface water coming across the landscape trying to get into the river. There was a bit of it that's come over the top, but we have modified these rivers so much to disconnect them from the floodplain. So we've embanked them. Actually, we know from the Adur, we've done a lot of modelling on the Adur, We know that these flood embankments don't actually prevent flooding, and in many ways they can make it worse because the water can't drain away from behind them. So once it's full, it's like having a bucket full of water. Next time it rains, there's no space in that floodplain to store any more. So it keeps getting wider and wider. So we know that these are problematic. Um, we've dredged them. Dredging's a great historical kind of management. We've created really deep channels. Uh, we've removed habitat through dredging, but it also speeds up the flow of water. And we know that we don't want water to flow particularly fast down to the bottom of the catchment because that's where the flood risk is, especially in tidal areas. But dredging, if it's, also can destabilize banks uh, as well. And again, in our modelling and investigations into these embankments, we've done lots of bed level surveys of the River Ada. So we were comparing them to bed levels of 25 years ago, uh, and there's been absolutely no change in the bed level of the river. So there's been a lot of call to dredge out the river in order to prevent flooding in places like Bramber. But actually, since the Environment Agency stopped dredging, there has been no change in the bed level. So it just goes to show that in some circumstances, we don't actually need to be dredging. It's not actually doing anything. I do caveat that with that doesn't apply everywhere. There are parts of the world and parts of the country where dredging is part of a necessary kind of flood management activity. But we've also drained, our landscapes and our floodplains have been designed to be drained. So everything's allowed to drain away. So we're not holding water back on the floodplains. We're not creating wetlands. We're confining water, kind of ditch networks that then drain out as soon as they get to a certain level. So we've been draining, deepening to carry more water in rivers, and then embanking them and disconnecting them. But we are looking at how we can change that. This is kind of an example of this is Lewis Brook. So this is over in the south of Lewis. We'll come back to this a bit later. We've done a big project here. But this was Lewis Brooks in March 2022, and it is completely dry. You cannot see any water on that landscape whatsoever. It's designed to be drained into the main River Ouse. And this is a picture of Elmley Marshes, which is a national nature reserve over in Kent, uh, basically from the same time period. And you can see how wet that actually is. You can see that network of habitat and ditches. It's still a farmed landscape. It still has grazing all over it, but it's also a kind of really functional wetland habitat. If you get the chance to go to Elmley Marshes, I can highly recommend it. But it just goes to show that how much we're draining our landscapes that kind of during periods at the end of the winter when these things should be wet, they are actually quite dry. So features, what about features in rivers? Features and habitat in rivers, very important. So we're going to talk a little bit about wood. It's really important. Wood in rivers. We used to remove a lot of it, even back when I started. The kind of if a tree fell into the river, the Environment Agency would be called and they'd dash out and they'd take it out of the river. Mainly on the pretense of flood risk management, but also because they look messy. Looks a bit messy if you've got wood all over the river. So we've got this kind of legacy within our rivers of removing debris and removing certainly wood from them. And what rivers need to be is messy. The messier it is, the better it is, as far as I'm concerned. Uh, so just going through this picture, this is a good bit of river. But why is it a good bit of river? Well, it's dynamic. It's got lots of processes. You can see lots of different things happening in that short section of river, and it's got lots of features within it. This is woody debris. So we're going to talk about the contribution and what those bits of wood are doing to this bit of river. So in its own right, it's providing habitat for fish. So fish hang out underneath the wood. They shelter from predators. They can use it to rest. It's good for inverts, so it's good food source for uh, fish as well. And it also provides perching for things like kingfishers. So great stuff. It's also changing the flow. So you can see to the left of the screen there, you've got still water. You've got, as you come over to the right, it's getting faster and faster as it moves through the system. And that's providing oxygenation. And oxygenation in rivers really important. Everything in the water needs oxygen to survive. So trying to create oxygenation is a good thing. And it's doing this. So where it's slowing the water down, it's enabling sediment to drop out, and it's creating a bar, which is in the big circle, that will vegetate up. Uh, and beyond that bar, because of the scour and the eddying that's created by the bar and the wood, it's created quite a nice deep pool. And again, fish like to hang out in quite nice deep pools, especially when it gets warm. It also gives them, again, refuge from kind of predators. On the right, because of the formation of on the left, all the water's getting pushed over to the right-hand side, uh, and it's starting to erode the bank. You can see the bank is bending as the water's going around it. So it's starting that process of meandering the river through that kind of velocity change. And then in the middle here, where it's kind of slightly slower, you're getting the dropout of gravel. So this is a riffle. So gravel is collecting uh, behind there, and it's creating, again, broken waves. So you're getting oxygenation, but also forming spawning habitat and invert habitat. So that wood is creating a lot of these processes and certainly contributing quite highly to these processes. But in this picture, they're dynamic. They're going to move. They're going to wash away. Next time there's a big bit of flooding, some of that wood's going to disappear, but it will settle somewhere else. And where it settles again, it's likely to start other processes, and again start these kind of formation of these types of habitat again. But what's here will stay here. So the bar's not going to disappear just because the wood does. So you've kind of left with this legacy of quite a functional and dynamic piece of river, even though the woody debris has moved downstream. So this one is slightly different. This is again, this is a good bit of river. So these are trees. Obviously, they're creating quite a dynamic system, mainly because of the roots that are interacting with the water. Uh, so this is in an area that's completely flat. It's completely flat. It's got no gradient on it at all. And what the trees there are doing is they're squeezing the river. They're constricting the sides of the river, and they're speeding up the flow. And as they're speeding it up, they're deepening the bit downstream into a nice big pool. So you're getting broken water, and you're getting that kind of pool habitat. It gives you flow diversity. It also gives you, so there's your deep pool in front of the trees. The roots at the back there are deflecting water onto the other bank. So again, you're starting to see that kind of erosion and that kind of shape starting to form, that those bends starting to form in the river. And you get in these little eddying effects, creating these little backwaters here, and sediment dropping out of the top there. But these aren't going to move. They're not going to move for a while anyway. They will fall down eventually. So these processes will just continue, and this channel will continue to develop based on these kind of processes that are going on. They will eventually fall over, or their browse will break. And then we refer back to the picture I showed you just now, where they will start to do something else. So it's really important. Wood is a really important part of creating these features, and these features are all important for river health and creating good rivers. So how do we know where to do this? We use lots of data. So we use lots of habitat data. We do lots of surveys, river habitat surveys, river condition assessments that are looking at whole subcatchments or just individual reaches of river. We do a lot of invertebrate sampling to look at habitat quality. And everything there that's in bold is all done by our kind of volunteers under a citizen science program. But we can actually look at long-term river health. And then what do we do? This is quite a cool little project over on the Ada. So this was a very long, straight, low velocity stream. You can see gravel, silted up gravel in there, and not much is happening. And all we did here is we dropped a couple of logs in to the river. So there's one further upstream as well. But how these logs are changing the flow velocity is cleaning those gravels up. But also they're creating those pools on the left-hand side. So these are quite cheap, simple interventions that we use in order to just try and kickstart some natural processes from happening in river systems and alter flow. What else? Clean. They need to be clean. Rivers need to be clean. And we're just going to touch, I'm going to say this because it is important that water quality is highly complex in river systems. And yes, water company sewage discharge is a major issue to the health and cleanliness of our river. But so is a lot of other things. We have a lot of problems from agricultural, road, and industrial runoff. These two pictures here, the big picture on the right is actually up by Burgess Hill from a pollution that came out of an industrial estate near Burgess Hill. So that's just chemical pollutants coming down the river. And the one at the bottom there is actually an agricultural pollution over on the Ouse from slurry being released into the river. There's also a lot of problems with plastics and human litter and human waste and all kinds of stuff. So we've got to look at all of these together. Just concentrating on one thing is not going to fix some of the problems that we see with the kind of quality of our water. We use a lot of data to understand river health and water quality. We use chemical sampling. We use river fly monitoring. We use long-term data collection, and it enables us, by putting all this data together, it enables us to start modeling where high impact areas are likely to be, but also where we can implement solutions. So where can we look at these maps here are around agricultural runoff and where we have opportunities to actually stop diffuse pollution from getting into river systems. We also do a lot of partnerships with universities. We've been doing a lot of stuff around pharmaceuticals and PFAS at the moment, certainly into groundwater systems. So this is a project we did to try and tackle some of these. This was a big project over near Sompting. This is a chalk stream. You can see the state of it in the top pictures there. It's not looking very chalky. This was about the worst bit of river I've ever seen. It fails for everything. It was full of various contaminants from leaching from landfill. It's next to an industrial estate. It was full of things like boron and cadmium and an uncapped landfill also sat next door to it. So, and it also took all the road runoff from the A27. So this was a pretty knackered chalk stream, kind of pressured from many years of problems. In 2010, the Environment Agency came up with a scheme to fix this, but it was decided it was too complicated and expensive, so they removed it from their program. I met the landowner a couple of years later, and he said, "Are we going to do this project? Because we're not going to build on it." So I thought, let's do the project. How hard can it be? And actually, this one was pretty hard. This was full of problems. There was multiple services across this landscape. There was the GlaxoSmithKline effluent pipe. There was two sewers, the Rampion offshore wind cable, and the main power cable that went from Worthing to Stenning, all crossed over where we wanted to do our project. The whole land was contaminated. That picture at the top right there, all that black stuff is arsenic in the ground around where we wanted to dig the channel. And it was also quite a site of archaeological importance in terms of early human habitation. So it was quite hard, but we cracked on anyway. It took a long time to develop it. 2015, I met the landowner. I spent about a year panicking about the fact that I'd said we would do this project. And then we were very fortunate to get some funding from the Heritage Lottery Fund. We had an awful lot of help and support from the Environment Agency and the landowner and lots of other people in kind of working out how we did this. We got some lottery funding, and by 2018, we had put in our kind of full application to the Lottery Fund, and we were very grateful for them taking a chance on us to deliver this project. And the reason I put this timeline up is because it's important to understand how long some of these things take. So this was 2010, this was originally thought about. It took 8 years for us to actually get the funding together to do it. But once we had the funding and we had gone through all of that pain, between March and September of 2019, we went to tender and then delivered it. So it just goes to show once you're in a position to do it, you can move quite quick. But that process is quite time consuming and also can be quite expensive. But it was worth it. This is what it looks like now. We moved it out away from the industrial estate, out from under the pipes and underground, away from the landfill site. and built in that bottom middle picture, built lots of sediment traps right at the top. So all of the sediment and all the historic sediment that will be coming into it is actually captured in these traps at the top. And because the land is contaminated, we don't have much trouble with actually disposing of it again. So hopefully you can just see from those pictures that the kind of improvement that that's made to the overall kind of health and quality of that bit of river. But simplicity, that's big. It's complicated. It took 9 years to do it, 10 years to do it. Buffer strips, really important to kind of river health, especially for agriculture. You can see a nice example on the right, not such a nice example on the left. And I think this is one of my most, this is in the West Country, but this is one of the most powerful kind of pictures I've ever seen, or examples I've ever seen of how simple interventions can make a massive difference. This is a quite heavily farmed and grazed piece of land, and our Rivers Trust down there put up some fencing along the river, and within about 18 months it looked like this. So again, just removing that kind of pressure with some fencing has actually created what is quite visibly a much better section of river. And sometimes we're coming to the end. Sometimes we get to do it all. So this is a project that we've just finished over in Lewes. Again, that picture there, that's a chalk stream, would you believe? Full of parrot's feather, full of duckweed. It actually had virtually no life in it whatsoever. It had been moved to make the A27. It'd been moved around all over the place. So here it is from the top. You can see it in that picture, in the kind of middle of the picture, the luminous green line just to the south of that line of trees is the river or the stream as it flowed through there. So with this, we started off back in 2019. So just as we finished the other one, what are we trying to do? And can we make this stream better? You couldn't work within what you had. It was just too degraded. And again, very grateful to the National Park who gave us some funding to actually just develop some ideas. The idea, restore it back to wetland. So this is the top of Lewis Brooks where I showed you that dry picture from earlier. We wanted to create wetland, put the habitat back to what it should be, get better biodiversity, and also get some kind of flood and drought resilience back into the landscape, and remove the parrot's feather. Here was my idea. Apparently, this was my sketch when we first went there. Apparently, this is not good enough in order to build a new river channel and wetland. So, but this was the general idea. Could we create a channel that went through the middle of the floodplain and then surround it by wetland and infill the old channel? We gave it to some designers who came up with this, which I accept as a slightly better kind of interpretation of what we're going to do. And this was 2021. We got these designs. So it took a couple of years to get to this point through all the processes that we had to go through. But you can see all the dark red areas are the deep bits. And as it gets lighter and lighter, it becomes shallower and shallower. So the idea being that you create a river channel that's then connected into this wetland environment. 2023, we finally got planning permission. It took 2 years to get planning permission to do this. One of the biggest objectors to doing this was actually Natural England, because we were interfering with a triple SI. So it took a couple of years to convince them that this was actually a good thing to do. And then we began to construct it. You can see this is the kind of process of constructing, of stripping the land, digging through the river channel. The picture on the bottom left there shows kind of some of those habitat patches and kind of wetland features that have been formed. And then the bottom left there is bottom right there is kind of getting towards the end. This is what it looks like now, or this is what it looks like at the moment. You can see in the we weren't allowed to plant it, so naturally we wouldn't allow us to plant it. So it's got to naturally regenerate, which is why the bottom right there still looks quite bare. But that's what it looked like in the middle of summer this year. So whenever in the drought period, we had lots of bits of river drying up, and this was working as we wanted it to. And it's also smashed the biodiversity back into the site as well. We've seen a huge increase in lots and lots of different species, and actually the return of all but one of the triple SI species that were missing from the site have come back as well. But again, this is the timeline. And again, the cost. This one was expensive because of where it was and what it was. So you can see just to get to the point of constructing it cost about £325,000. It only cost £400,000 to then construct it. And for us, one of the constraints to doing projects is those costs in that blue and orange area. Once you've got a nice, pretty drawing and an idea and planning consent, getting the money, quite simple. But getting to that point can actually be quite difficult to get funding for. So again, very grateful to the National Park and very grateful to Lewes District Council, who kind of took a chance on this being a good thing to do. So summary, what have we looked at? Rivers, what makes good rivers? They need to be diverse. They need to have lots of different features, lots of things going on. They need to be messy. We need to kind of allow them to move around. If we try to constrain them, then we actually diminish some of those processes. So actually allowing rivers to move and be dynamic and change. They need to be free from pollution, but it's a whole cocktail of pollution and not just a kind of single source. And we need them to be connected to floodplains. They are floodplains to enable them to flood. There are lots of ways to do this. We can do large scale things, but we can also do some really small, simple things to actually make these rivers better. And simple approaches can have really, really big and instantaneous impacts on the health of our waterways. But everything takes time. And there's no a single thing that I've shown you there that didn't take more than a year in order to get consent and funding in order to do even dropping a log into the river. But there's lots more to do. There's always lots more to do. And obviously we encourage you to get involved and support your local Rivers Trust. And that's it. I hope that was interesting.
Oh, thanks very much, Pete. That was fantastic. Really, really good explanation about what river restoration is and some really inspiring projects that you've been involved with. It's really nice to have those good news stories. I think we could all do with some more good news stories right now. So that's really lovely to see what you've managed to achieve. We've got a few questions that people have put in. If anyone has got any questions, then do add them to the Q&A, and we'll try and make an effort at answering those questions now. So I'll just go through them in the order that they've come in. So a question from Andy Morgan. How did you get funding to do the re-meandering?
The first remeandering was done, so that was done through government funding. So this was back in the day when looking at river catchment approaches was being piloted. It's amazing to think that we've only thought about rivers as catchments and since about 2010. But back in then, there was the Ouse Adur was actually one of the pilot catchments to see what we could do in partnership. So that was a project that was done with the Rivers Trust and the Environment Agency, and it was funded directly through the Environment Agency.
Okay, thank you. Angela Ward asks, hi Angela, does in-channel rewiggling reduce water capacity?
It does reduce water capacity slightly, but not to the extent where you would ever notice any difference. You are, when you're not reducing capacity enough to increase flood risk. Once things are inundated with water, the difference in capacity is so minimal that it doesn't really make any difference.
Thank you. Another question from Andy. When you drop logs into the river, do you have to get EA approval?
Yes, so everything we do, so everything that happens within 8 meters of a river, or in fact any kind of watercourse, requires consent. So where we drop those logs into the river, that was on a piece of main river, so that's under the responsibility of the Environment Agency. So yes, you either need to get a flood risk activity permit, or for some of the things we do, you can now get exemptions. So there are certain things that you can apply for an exemption for, and small scale habitat improvement is one of the things that you can apply for exemptions for. But yes, if it's not on a main river, then we have to get ordinary watercourse consent from the council. But effectively, everything we do with water requires some kind of consent, and they can take anything from about 8 weeks to, I think that we're doing a project at the moment where we've been waiting 9 months to get the consent back from the Environment Agency. So the consenting is a big barrier, not a barrier, sorry, it's a big time constraint to delivering kind of improvement and quite a cost.
Yeah, I think there's been some huge delays in getting the flood risk activity permits, the FRAPs as people call them, through the system and approved. And it would be nice if that process could be sped up a little bit and made more user friendly for people who actually, are trying to do good things for rivers.
Yeah, and I think generally consenting, planning consent is another one, and sometimes we have to get to do the Cockshoot project, the one on Lewis, we had to get a FRAP, ordinary watercourse consent, and planning consent to do that project. And uh, but I think there is a starting to be a shift in the consenting authorities' approaches. None of those consents are designed really for nature restoration projects. They
Mhm.
are designed for development, and I think we're starting to see that consenting process be such a barrier to doing some things that uh, we're starting to see conversations around how those processes can be made much simpler for positive intervention.
Yeah, absolutely. Okay, question from Katrina Murray. How to address concerns from farmers about brackish water contaminating agricultural land?
Yeah, I mean this is a problem. So uh, it depends, obviously. So where we do the ADA, so we're looking at whether we can remove those embankments from the ADA. That is something we are looking at, and what the implications that would be on, um, well, lots of different things: flood risk, drainage, agriculture. With the expectation that we can find a solution that actually benefits all of them. One of the problems there is that that water sits for about 4 foot deep for about 6 months. So the land's a lot of the landowners there basically very restricted in how long they can use the land for. So there we've been doing a lot of saline testing. So we've been doing a lot of salinity testing and then working with vegetation experts, a lot more than me about what kind of changes you would see up the valley. What that's shown us there is that south of Bramber, you see massive impacts. You effectively create salt marsh and mud flats, and you change the landscape quite radically. As you start getting north of Bramber, yes, it is. It's still slightly salty. It's still brackish, and you would see some vegetation community change, but not to the extent where it become uh, unusable as agricultural land. I guess what we're looking at with that kind of project is we're looking at what the future of that landscape actually is anyway, and whether we can use mechanisms around financing to get in front of that. So some of it will be realigning embankments, so actually pushing them backwards. So you're losing some of the land, but you're still maintaining the rest of it. Uh, but I think with likely tide height rises over the next 20 years, we see a lot of these embankments will start to become overtopped anyway. And then you've got the problem of drainage. So it's a very complicated issue. And we're seeing saline intrusion through groundwater in lower parts of the catchment already. Certainly around Newhaven, we're starting to see the areas around Newhaven getting quite impacted by saline intrusion from sea level rise. I don't have the answer, I have to be honest. I think it is a big problem, and it's definitely something that we need to be thinking about not into the future, but now as to how we start to kind of tackle some of these issues.
Yeah, absolutely. And I live in Chichester. I've heard from landowners around Chichester Harbour area about more saline intrusion from groundwater getting into their fields, and there's fields where they're finding it very difficult to grow crops now because of that.
And it's a big risk, so a lot of our water comes from down the bottom of the catchment as well in the aquifers, and so the kind of saline intrusion into that groundwater system is well should be a major concern.
Absolutely. Okay, a question from Liz. We live near some of the headwaters of the River Arun. Do springs and streams also need to wiggle?
Yeah, I mean, look, not everything needs to wiggle. So we don't expect the whole thing to wiggle constantly. And the head streams, it depends on where the head streams are. Obviously, some of the head streams you get um, a lot of kind of deep, steep-sided galleys. You've got gills, you've got all kinds of things, and they are highly valuable habitats in their own right and shouldn't be touched. Just to put some wiggles back into a river, the benefits come uh, the further down the catchment you go. And a lot of that re-wiggling is restoring the historic courses of the channel where over the last 300 or 400 years and even beyond that, we've actually straightened them, whereas you don't tend to get that up in the head streams, and the head streams tend to be more naturally what they want to be. So I would say I wouldn't rush to wiggle everything. It does depend on kind of its condition and why it's in the condition that it's in.
Thanks, Pete. Marcel asking, do you do anything to reduce the impact of road runoff? So has that been part of any of your projects?
Uh, yes, we look at road runoff. Road runoff is a big problem. The problem you have with road runoff is that it generally runs from a pipe above the river directly into the river, so you don't have a lot of space. We've just actually started a project uh, which is looking at the impact of road runoff from the A27 and how you can actually mitigate road runoff in quite constrained landscapes. So yes, but we're not doing it successfully. It's easier in urban areas. It's actually easier to kind of tackle it in urban areas because you generally actually have a bit more space. You can tackle it in kind of curbs and road verges and stuff. Uh, but in more rural locations, that water is just funneled directly into the river, so it is very complicated. It's very difficult. You need to try and put it through some vegetation before it gets to the river.
Thank you. If anyone is interested in the subject of road runoff, then do have a look at one of our previous webinars, which was with Joe Bradley from Stormwater Shepherds, which was all about road runoff, and you can find that on our YouTube channel if you look for Western Sussex Rivers Trust on YouTube, you'll be able to see that. And that was a really excellent presentation by Joe about road runoff. The question from Louisa, where a river or stream forms a boundary between two private properties, how have you managed landowners' differing expectations and priorities? That's a good question.
Very good question. I think, again, this is part of one of the reasons it takes a long time to develop things because, we are entirely reliant on the goodwill and relationships of landowners and where we're doing things, if we're doing things that require us to do things on both banks of rivers, then we need both sides to be on board with it. Uh, Compromise is probably the answer. I think if we're working and we've got a party that is absolutely adamant that they do not want to see anything done, and then we are a bit stuck. We can work on one side of the river and we can improve one side, and we've done that. It's kind of it's a bit like that Sheffield Park thing where you've got woodland on one side and we want to do something on the other side. So sometimes we kind of just restore half the bit of river. Uh, the Obviously if we're re-meandering things or we're kind of realigning channels, then we do need both sides on board. But again, if we don't one of the reasons for that is because a useful thing for us to be able to do is to infill the old channel because it gets rid of all the soil. But obviously that then starts to join land holdings together. We don't have to do that. So we have done them before where we leave the old channel in situ and that still forms that boundary. But it is absolutely vital to kind of success that we try to work out how we find that common ground in order to kind of have the biggest benefit we can. But it can take a long time. Some of the projects we're delivering now, we've been talking to landowners about for 10 years, 8 years. We just removed a big weir that up in the north of the Ouse where one landowner was desperate to get rid of it and the other landowner wanted it to stay. And it has taken us 8 years to convince both sides that this is a positive thing to do, and it doesn't it's not going to create any detriment, but really important. It's a really important part of what we do.
Yeah, yeah. And sometimes that when people have got attached to things and maybe you think there's a heritage sort of aspect to it, it's people don't like to see change quite often, do they? So okay, James McDonald, we'd like to thank you for your great presentation. How easy or hard do you find working with the EA and other organisations?
Can I ask him who he works for? Uh, I think I mean, we have a very good relationship with a lot of different organizations built over many, many years. So I would say for us, uh, we enjoy working with people. We actually, we recognize the fact that we need to be able to work with people. A lot of the stuff that we do does require the input of others. I'd say, the Environment Agency has changed a lot in the 15 years I've been doing this, and I think it's become a lot harder for the Environment Agency to work with us. I don't think, they have much less resource, much fewer staff, a lot less money. When I started, there were 6 floors of people in Gilbourne House in Worthing, all working for the Environment Agency, and by the time they moved last year, I think you'd struggle to have filled one of those floors. So I think it's harder. It is harder in that circumstance, but there's still a great deal of willingness, and there's everybody that's trying to restore rivers and make rivers better is in my experience doing the best that they can do with the constraints that they have. So uh, it's a good time for rivers. They're suddenly everybody wants them to be good, so it's good, and I think there's a lot of momentum behind making it better. So we generally uh, get on quite well with a lot of other organisations and community groups, and it's a whole catchment thing. We need everyone behind it.
Yeah, absolutely. That kind of partnership working is key, isn't it? Question from Ray Smith. You've spoken about the challenge, time, and cost required to get to the point of submitting proposals for funding. You've stressed that everything takes time, but have you developed insights or tips on how that could be dramatically shortened? I'm reminded of the COVID experience during which vaccine development was dramatically shortened. Could times be compressed by using specialist support or admin support?
Yeah, I think one of the big I mean, funding is always an issue because you're asking people, that initial funding, you're asking people to give you money to try and develop an idea, and that's always going to be quite a hard sell. Even with lottery funding, the sub project in Sompting that was funded by the lottery, that first stage application to the lottery takes ages. Takes about a year to write a funding application to the lottery fund for a project like that. You're hoping you're going to be successful, but trying to get somebody to fund you to do that is difficult. So we fund a lot of that ourselves. I think yes, there are ways of doing it. I think as we hopefully see the consenting process changing and becoming easier, uh, because that is a massive time barrier to doing things. Uh, Obviously, the more experience we get, the more we know, the more evidence we have, the easier the conversations become with landowners, with people that own land or manage land. We can show that this works, we can show the benefits, and we can show the limited impact that, the vast majority of it actually has over the longer term. Uh, Funding is always going to be an issue. It's always going to be an issue, and effectively, the way the funding's going at the moment is everything's moving into being much bigger. So everybody wants big landscape scale things. That takes time. We've just submitted a £100 million application to DEFRA to do a big project. Well, from the top to the bottom of the Ada, uh, involved 28 farmers trying to align 28 people together and generate all the evidence that you need. I mean, it took 2.5 years just to get the development stage of that project to the point where we could submit that application. So I think there are ways of speeding it up. I think the most obvious way of speeding it up for us at the moment, for the majority of what we do, is not waiting a year for consent. Is probably the biggest time constraint. But the more we do, the more we learn. We learn how to do things quicker. We worry less about it. The first time you do something, it always takes longer because you're always wanting to make sure that you are getting it absolutely right. And then the second time it gets a bit quicker, and the third time it gets a bit quicker. So I think you can speed it up for sure.
A couple more questions. David asking, please could you describe how you might tackle a tidal river such as the Lower Arun below Pulborough?
Uh, uh, I think, you know, tidal bits are interesting because, again, we constrain them. So if you think about what we do to tidal rivers, we've stopped tides going up river systems. So we generally build big barriers, big weirs. So the Ouse, the Ada, I believe the Arun has a barrier at some point that is stops the tide going up any further, which is in some ways quite good because otherwise you'd have no freshwater environment in some of these flat kind of landscapes. I think one of the problems we've got is coming back to the Ada is that kind of constraint that we put on them. They're very much managed for flood risk, and because of the pressures of fluvial flow, so the kind of river flow that's coming down and the kind of tide coming up, if you own land in those parts of the river system, uh, it is it's very nerve-wracking to make change because they're under quite a lot of pressure from some of the things we've talked about already. So I think it's about kind of to me it's about looking at, again, I said it a bit earlier, it's about looking at like what's the future of this landscape if we do nothing, uh, and then trying to work on solutions that uh, kind of come up with that compromise between we need food, we need these agricultural landscapes, uh, but if we're going to lose them anyway, how do we best manage that now rather than in 25 years' time we're sitting around going, oh, maybe we should have done something about that. So I think complicated groundwater, surface water, tidal water, very, very complicated to work out.
I've just got one more question. I know we're slightly over 8 o'clock. Olivia, be interested to know if the trust engaged in any BNG habitat bank projects. So that's biodiversity net gain for anyone who doesn't know BNG.
Yeah, we do. We're kind of finding our way through it. We've done some kind of river restoration projects through BNG directly, so with watercourse units for BNG, and a lot of that ADA project that we've put into depth for a lot of that is tying in with BNG because again we see it as a way uh, of kind of compensating landowners for some of what's happening. And again, if we're looking at that future scenario, if we get a front of that and we can kind of BNG this through that process, uh, then yeah. So yes, we do. BNG is very complicated. It's constantly changing. I think, and for watercourses, it's difficult because they want to see improvement in a bit section of watercourse. And hopefully, one of the things you've picked up through this talk is that we need them to be ever changing. So we can't fix habitat in place so that in 30 years' time, that bit of river looks good.
Mhm.
So trying to get the powers that be to kind of think about rivers slightly differently in terms of BNG, because the benefits you see might not be at the location that you do the work. If you remove a weir structure, for example, the benefits to that are over many, many, many kilometers of river, not in fact, what you can do is reduce the fish population at the site because you're allowing them to move. So BNG for rivers is something that we have spent a lot of time kind of discussing with Natural England and around. It's just not really working for us to take the risks around doing it. But it's the best mechanism we've got for long-term funding for terrestrial and uh, river kind of improvements.
Yeah, interesting. Thank you, Pete. Thank you so much, Pete, for doing that for us. It's really, really interesting. And we will make the recording available on our YouTube channel. So if anybody wants to see it again or missed some of it or thinks they want to share it with anyone, I'll let everybody know when that recording is available. And do check out the YouTube channel for the previous webinars as well. Some really, really good ones on there, particularly covering issues around water quality and pollution. And that was really great. So thank you very much, Pete. It would be
Thank
great if
you.
you could share the slides as well. I think people would like to see those if that's possible.
Yeah,
You
we can
can
do
do
that.
just
Thanks very
email
much
them
for
to me,
inviting
then
me.
I can share them. Great. Well, thank you everyone, and enjoy the rest of your evenings. Thank you. Bye.